Okay, here's the exact same shape of circuit, different values for the resistance, and we want to figure out how we're going to replace all of these with a single resistor. So again, you can see here's where you're going to start. I'm going to start with these two. I'm going to turn them into a total resistance for those two. So they're in parallel. I'm going to go 1 over 10 plus 1 over 10. A trick, when you have a 10 and a 10 and they're in parallel, they end up being half. So that's 5 ohms. So I'm going to replace this, and now notice though that this one's slightly different. I've still got a 5 there that I've made. There's my 3, and down in this bottom junction I've got my 12. So 5 ohms, 3 ohms, and 12 ohms. On the last one, it was series at this point, but this one's not because I've got a junction point here and there, so now these two are still in parallel. So these top two, those are in series. Okay, so I can figure out 5 plus 3, that's 8 ohms. So I can replace that with an 8 ohm. And this bottom one is still 12 ohms. So that's 8 ohms there, 12 ohms there. And now I'm going to find my total resistance for this parallel. 1 over 8 plus 1 over 12. So that's going to give me 4.8 ohms. That's my total resistance. 4.8 ohms. So that's this is the one theoretical resistor to replace all of these. And again, you're drawing yourself diagrams so that you can work your way backwards when the questions start. Okay, so there you go. There's your second equivalent resistance.